This video will demonstrate how to use a half-angle identity to evaluate 6b. So what we're going to do is we're going to take 8 tangent of x halves plus 8 cosine of x tangent of x halves equals 1. We're going to solve this equation on an interval from 0 to 2 pi. So one of the things I noticed right away on this is that you could take out a common factor of 8. Not only could we factor out a common factor of 8, but each of these have a tangent of x over 2, or x halves. So we're factoring that out of this binomial up here. So what's left is a 1 plus cosine of x equals 1. Okay, so now at this point what we need to do is we need to insert our substitution for our tangent of x halves. So what we're going to do is we're going to come back and get our half-angle identity formula for that. And I'm just flipping through here. There are 3 different versions of that we can use. I'm going to use the version that I think is probably the easiest to work with, and that is for tangent of x halves, let's go 1 minus the cosine of theta all over the sine of theta. Just trying to double check that before I wrote it down. We got to take that times 1 plus the cosine of theta, or I guess I should have put that other one as x. So let me come back and replace that. I read the formula right out of the book, and they use thetas, but our variable in this problem is x. So instead it's going to be 1 minus the cosine of x all over the sine of x, and that's equal to 1. And this is all over 1. So now what I can do is I can multiply our 2 middle terms together here, and that means I got 8 times. We're going to square, well, basically FOIL this, and they're conjugates, so all I have to do is worry about the 1, and then the minus cosine squared of x. That's all over the sine of x, which is equal to 1. And 1 minus cosine squared is equivalent to a sine squared by the Pythagorean identities. So that's a sine squared of x all over a sine of x, which is equal to 1, which means we have 8 times the sine of x, which is equal to a 1. So now you want to get the sine of x isolated, so I'm going to divide by 8. So the sine of some angle is equal to 1/8, which means the angle we're looking for has a sine value of 1/8. Now that is not one of our memorized triangles. It's not one of our 1, 2 square root of 3s or 1, 1 square root of 2. So we're going to have to rely on some technology to help us out to find that angle. So I'm pulling up the calculator, and I want to make sure that well, I don't know if it really makes a difference. I'm going to make sure it's in degree mode, I guess. I don't think they specified, so it's in degree. Second quit. I want to clear that out just to make that a little more clear here. So we're doing the inverse sine of whatever 1 divided by 8 is. And the angle it says it is about a 7.2 degree angle, so that's one of them. But sine values are not only positive in the first quadrant, which is the one that we just got, it is also positive in the third quadrant. So in order to get that, I'm going to have to take 180 and minus the 7.2. So that's not a big deal. 180, subtract our 7.2, and we should have this 172.8. Oops, 172.8 degree angle. Okay, 172.8 degrees. So those are 2 angles that have a sine value of 1/8. That was applying our half-angle identity for tangents, so you can see how we can come back and use half-angle identity to solve equations as well.